All right, Scratchers. Last time we added animation to our P38 so that it looks like the propellers are spinning. This time we're going to add movement controlled by the player. So if we think about how we want to trigger movement, a lot of times we think we want to press keys. So in this case, we'll use the left and the right key and also the up and the down keys. And keys make us think of events. Pressing a key is an event. And if we look in our hat blocks, you'll notice there is indeed a when a specific key is pressed, which includes all of the arrows, any key, and then A through Z and 0 through 9. So all of the keys on the keyboard that we might want to use. So if I press my left arrow, for example, I want my plane to go left. What's going to make my plane go left? Well, let's look at our motion blocks. Now, previously, you may have used the move blocks. That moves the plane in the direction, or the sprite in the direction it's currently facing. And if we do this, we'll notice something strange. Our plane actually, when we tell it to move forward, moves sideways. And that's actually because our sprite, the forward direction is to the left, and our sprite is actually rotated. So Scratch expects sprites to face to the left, kind of like the Scratch Cat sprite normally does. We could rotate this so that it faces right, but then that move really is only going to move us forward. It's not effective for what we want to do here. So instead of using those, we're going to actually use the coordinate system. Remember, Scratch uses the Cartesian coordinate system. The y-axis goes upwards and downwards, and it gets bigger as you go up and smaller as you go down. And the x-axis gets bigger as you go right and smaller as we go left. So if we want to go left, we want to change our x by some value, and we want that value to be negative. So I'm going to use -5 here. And if I click on that, notice that slides our plane a little bit to the left. And likewise, if we do change x by a positive value, it's going to slide our plane to the right. So when I click that, you can see that we're moving our plane left and right. So we want this to happen when that key is pressed. And it looks like we're doing that just fine. Now I'm going to add the when right key is pressed here, the right arrow. And now if we tap that key, it behaves exactly like we expect. What happens if we hold that key down? Did you notice that there's a bit of a momentary pause when we press that key? That's not really a problem with Scratch. That's more a problem of how operating systems and computers read our input. So when we press a key, the computer actually will go through several hundred cycles, that's processing steps, while we're still holding down that key. Even if we hit it as fast as we possibly can to the computer, that's going to seem to take quite a while. Us humans are slow compared to computers, especially in terms of our reflexes. So the computer isn't sure if we actually mean to hold the key down or if we just happen to be tapping and we're just too slow to get our finger off the key fast enough. So the operating system manufacturers, so Windows and iOS and Linux and all of them, have added a little delay in processing after the first key. So that the first time you press the key, it says, oh, you pressed the key. Then it waits a little while before it starts saying, oh, actually, you're holding that key down. You're holding that key down. And in that momentary pause while it's waiting to determine, are we really holding the key down, it's not telling Scratch that the key is being pressed down. And that's what that little momentary hop there is about. It's basically because Scratch hasn't been told that you're actually holding the key down yet, it just assumes nothing is going on. So while this will work well for like when we start firing our bullets, it doesn't lead to satisfying motion if we actually hold the key down. So how can we actually make it more satisfying, more the way we want it to behave? Well, there's another way we can determine if a key is being pressed, and that's this Boolean block out of our sensing menu, which senses if a key is actually being pushed down or has been released. So if the left arrow is pressed, or if the right arrow is pressed, we want to move in the appropriate ways. Now, this is a Boolean block, which means it has to plug into a Boolean hole. We can't actually connect, for example, change X to this. There's nothing to connect to. So we're going to go back to our control blocks and look for one that has that socket. And the if-then is a pretty logical choice. It says if happens to be the left arrow is pressed, then we're going to change that X. We can do the same thing for the right. And now we need something to start this. So we're not going to use these control blocks anymore. Instead, we're just going to say when that green flag is clicked, if the key is suppressed, go ahead and change that X and Y axis. Now if I restart my program here, and I hold left, I press right, I'm pressing them right now and nothing is happening. That's because as soon as I hit that green flag, notice how these flash. Notice how this one is yellow. That means we're actually still executing the script. These ones just flash because they executed for just a split second. They checked to see if that key was pressed. It was not, so it skips down here and it's done with the script, so it stops executing. We want to actually be checking continuously, are we pressing the left button or the right button, which brings us back to a forever loop. We basically want to continually check that we're actually pressing those keys, and whenever we check if we are pressing the key, we're going to move our sprite. So let's restart that program. Notice now these are all highlighted in yellow. That means they're continuously running. And now if we hold that key, we get that smooth motion we were looking for. So at this point, I'm going to turn it over to you to add forward and backward motion. And some things to think about is how much do you want to change that plane's position? Do you want it to move slower when it's backing up? Or do you want it and faster when it's moving forward, so you get kind of an illusion that you're flying very quickly and that you can't fly much faster than you're going, but slowing down, you can slow down quite a bit more? Or do you want it just to be constant, just like the -5 and 5 that we're using on the x-axis? Those are some things you can play with, figure out what you like, what feels good to you, and go ahead and program that in.